Okay, so we can work through one of these examples where we can calculate the chance that an unknown individual has this recessive allele if they're a carrier for it. So starting off, we can fill in the individuals that we know. So anybody who's got the trait is homozygous recessive. And then we kind of work our way up and then back down again. Or if you like, you can just remember some rules about these. So the first question here, what are the odds that the mother of the child down here, a child of a male or female sex, whether they have the allele or not? So the question that they're heterozygous. So the mother, this is this individual here, what are the chances that she is heterozygous? So you could remember that 2/3 rule. That'd be certainly the easiest way to jump right in there. The rule, again, for being 2/3 was that unaffected parents who have an affected child are both heterozygous. And if one of their children does not show the trait, we eliminate that possibility of being homozygous recessive, and the remaining possibilities are 2/3 of the possibilities. So she's got a 2/3 chance of being a big A, little a. And we don't know for sure, but 2/3 chance. So that's the answer to that one there. Moving ahead to the father here, same rules. So sibling again, we could fill in that these parents are definitely heterozygous. This person is 2/3 chance of being heterozygous. So uncertain. And then moving down to the father, that's the question here, the father of question mark. Here we've got a Punnett square where one parent is homozygous, big A. That's really not the parent we're concerned about passing on this little a allele. So we can do the Punnett square and just kind of keep in mind that we have a 2/3 chance for this arrangement. And then if that's true, then half of the offspring would be heterozygous. So it's a compounded uncertainty, 2/3 times 1/2, 2/3 chance that they are heterozygous, and then if they're heterozygous, half chance they would pass it on, equals 1/3. So maybe I'll fill these in as a little bit clearer. 2/3 chance, 2/3 chance, 1/3 chance. And then again, kind of working ahead, if these individuals are both heterozygous, then the Punnett square would look like this. Homozygous, heterozygous, heterozygous, homozygous. What are the odds? Oh, sorry, let me get to the next question here. All right, what are the odds that the child will be homozygous recessive? So that's a 1/4 chance here, but that depends on two other things happening. So basically, the chance of that being homozygous recessive is the chance that mom is heterozygous, 2/3, times the chance that dad is heterozygous, that was 1/3. And then if they're both heterozygous, we get the Punnett square here, and there's a 1/4 chance that their offspring is going to be homozygous recessive. So this is compounded to multiply out the numerators, 2, multiply out the denominators, 3 times 3 times 4 is 36. Simplify that down to a 1 out of 18 chance. So pretty low chance, but not entirely off the possibilities that question mark individual could be showing this trait. So this is a good example of a trait that's running in the family. You might be trying to avoid it. And if you had this for your pedigree, you could answer the question, what are the chances that we're going to have a child who is homozygous recessive and shows that trait? All right, moving on through pedigrees. We'll start a new recording here.